Hi viewers, welcome to Young Maths Academy. Today's class will be on inequalities. Okay, I want you to follow through the class and see how we deal with problems on inequalities. Okay, just as you can see on the board, we have the function f of x is equal to x squared minus 4x plus 4 over x intersects the straight line y equal to k. A, form a quadratic equation in x and k. B, hence find the values of k for which f of x has real roots. Okay, solution. So we have the function f of x is equal to x squared minus 4x plus 4 all over x. Okay, we are told that this function intersects the straight line y equal to k. We know that our y is always equal to f of x, and here we can see that y is equal to k, means y is equal to f of x equal to k. Okay, so that I can set this. If this is 1 and if this is 2, I can simply equate 1 and 2 from there, so that I say k is equal to, since k is f of x, k is equal to x squared minus 4x plus 4 all over x. Okay, so from there we can obtain our a. How do we do that? Okay, we can simply cos or multiply both sides by x, so that we have kx is equal to x squared minus 4x plus 4, and then we rearrange to get a quadratic equation, so that we say we have x squared minus 4x, this coming over minus kx plus 4 equal to 0, so that we can have x squared minus 4 plus k x plus 4 equal to 0. Factorizing this is same thing as x squared minus rewriting it as k plus 4 x plus 4 equal to 0. Okay, we've been able to obtain a part of the question by getting a quadratic equation in x and k. Okay, b says hence find the values of k for which the function has real roots. Okay, you can see we have natural roots. When in our natural root, we know that when b squared minus 4ac is greater than 0, we say we have real and distinct roots. Real and distinct roots. Distinct roots. Okay, and we know that when our b squared minus 4ac is equal to 0, we have real and equal roots. Real and equal roots. Equals. That's when we have x is equal to a twice. And for real and distinct roots, maybe we have x equal to a, x equal to b, and we know that when b squared minus 4ac is lesser than 0, we have complex roots, which is also known as our imaginary roots. Okay, just to bring your memory back to that, so we'll have to apply that here, since we are told that let's find the value of k for which f of x has what? For which f of x has real roots. So it means we will make use of b squared minus 4ac greater than or equal to 0. So because greater than 0 simplifies to be real and distinct, equal to 0 signifies to be real and equal, but it is not specified here either real and distinct or real and equal, or just real roots. So we make it greater than or equal to 0. So b squared minus 4 is greater than or equal to 0. So what is your b from this last equation here? Your b is the coefficient of x, so that we say our b is minus into k plus 4 all squared minus 4 into a. A is the coefficient of x, which is 1, and c is a constant term 4. Yeah, this has to be what? Greater than or equal to 0, greater than or equal to 0. Okay, minus k plus 4 squared, the same thing as saying minus squared or minus 1 squared is positive, so I can just write my k plus 4 squared minus 4 times 4 is 16, so minus 16 greater than or equal to 0. Okay, so I'll do work of this side. Okay, so that's here what we have. If I expand this, I have k squared plus 8k, expanding that, plus 16 minus 16 greater than or equal to 0. So I will have that. So that this is k squared plus 8k. 60 minus 60 is 0, greater than or equal to 0. K is common, so I have k into k plus 8 greater than or equal to 0. Okay, so we have to find the values of k for which f of x has a real root. So from here we will check, therefore at this point we have k equal to x squared minus 4x plus 4 over x. We know that we have our f of x is equal to k, that is k equal to this function. This particular function will have real roots if what? If now therefore this will have real roots if what now? Okay, we check from here if it obeys this rule. Okay, if k is greater than 0, you know we can say k greater than 0. K greater than 0 means any number greater than 0. So I will pick a number greater than 0, greater than or equal to 0 now. So any number I can text for 1. 1 is greater than 0. So I will put 1 here in this same function. So if I put 1 here, you know I have 1 into 1 plus 8 is 9. 1 times 9 is 9. 9 is greater than or equal to 0. It means for k greater than or equal to 0, also if I use equal to 0, if I put 0 here, 0 here, I have 8 greater than 0. It obeys this rule. So it means this function will have a real root if k is greater than 0. Also, I will check for k plus 8. You know we have k plus 8 greater than or equal to 0. If I move 8 here, I have k greater than or equal to minus 8. So I will check for a value greater than or equal to negative 8. So when any value greater than or equal to 8, for example, we have negative 7 is greater than negative 8. So if I test for negative 7 here, negative 7 here means I have negative 7 into negative 7 plus 8. Negative 7 plus 8 will give me 1. 1 by negative 7 is negative 7. Negative 7 is not greater than 0. It means k greater than or equal to negative 8 won't satisfy that function, that equation. So if k greater than or equal to minus 8 won't satisfy that, means the reverse of the inequality will satisfy that. And the reverse of greater than or equal to is lesser than or equal to. So means it is k lesser than or equal to negative 8 that will satisfy the function, that will make the function as real roots. Okay, this is how we solve questions like this on inequalities. Do subscribe to Young Maths Academy and follow up to get subsequent videos. Thank you.